Equilibrium of forces. In this video, we will briefly talk about equilibrium of forces and then solve some WASSCE past questions. Equilibrium of forces simply refers to the combination of forces that are balanced. So the forces are balanced in the sense that their resultant is equal to the zero vector. So in other words, the vector sum of all the forces is equal to 0. That is, if all the forces are added, you know these forces are vectors, they will be equal to the 0 vector. They'll be equal to the 0 vector. But before we add the forces, we can resolve them into components. So the component is given by cos, that's the magnitude of cos theta, where theta is the angle the force makes with the x-axis. So cos theta, and theta is the angle that the force makes with the x-axis. Then we also have magnitude of the force times sine theta. So we can use this to find the forces in the vector form, and then we add them. But we can also use the complementary relation. So we know cos theta will be equal to sine 90 minus theta, and sine theta will be equal to cos 90 minus theta. Now let us take some few examples. We have our first example here. We are to state the conditions for the equilibrium of a rigid body acted upon by parallel forces. So the conditions are that the sum of the clockwise movements about any point is equal to the sum of anti-clockwise movements about the same point when a rigid body is acted upon by parallel forces. This is one of the conditions for it to be in equilibrium. Then the next condition is that the sum of the forces in one direction is equal to the sum of the forces in the opposite direction. So the sum of the forces maybe in the negative direction should be equal to those in the positive direction, or those in the up direction should be equal to those in the downward direction. So say this is the tension, whatever the tension must be equal, the tension or the normal reaction, whatever is acting upwards should be equal to whatever is acting downwards, maybe the weight. Now we look at the next question. we have to explain the term net force from WASSCE May-June 2016. So net force simply refers to the resultant force resulting from the actions of a system of forces. So the total force resulting from the actions of system of forces is referred to as the net force. So if you have a force 90 Newton which is moving an object forward, then we have another force 30 newtons which is resisting the body, then the net force will be equal to 90 minus 30, and that will be equal to 60 Newton. Now let us look at this. The diagram illustrates three forces, T1, T2 and 100 Newton in equilibrium. Determine the magnitude T1. The magnitude of T1. Is it 130 degrees, 100 cos 30 degrees, 200 sin 30 degrees, or 200 over tan 30 degrees? Now we can see the forces T1, T2 and the weight. So the 100 Newton here is the weight. Now because they are all in equilibrium, we can resolve them into components. So we are going to resolve all the forces into components and then add them. So let's begin with the first one, which is the tension. Tension 1 is equal to the magnitude of the tension 1 force, the cosine of the angle it makes with the x-axis. Over here the angle will be 0 degrees, so cos 0 degrees. Then because it is negative, the x component is negative over there, we attach the negative sign. Then also for the vertical component, we have the tension of the force, that is magnitude of the first tension, sine 0 degrees. We can simplify this to get the component of T1 to be equal to negative absolute value of T1 times 1, because cos 0 is 1. Then we have magnitude of T1 times 0, because sine 0 is 0. Now this will give us the component of T1 to be negative magnitude of T1 0. So let's now resolve the second tension force. So the second tension force will be equal to, we are going to use the same procedure to obtain the component of the second tension force. Okay, now let me bring this down over here. So the second tension force, which is T2, will have component which is, we need to look for the angle it makes with this x-axis, which is 60. So we have magnitude of T2 cos 60 degrees. Then we have also magnitude of T2 sine 60 degrees. And we know in this quadrant all of them are positive, so we leave them like that. we can use the complementary relation to obtain that T2 will also have component magnitude of T2 cos sine 30, magnitude of T2 sine 30, because cos 60 is equal to sine 30 degrees. Then also this one will be magnitude of T2 cos 30, because sine 60 is equal to cos 30 degrees. Now we need the weight. We need to resolve the weight also. So the weight is also given by W is equal to magnitude of the weight, which is 100 newtons, times the cosine of the angle it makes with the x-axis, which is 90, so times cos 90 degrees. Then so this will be cos 90. So the vertical component over here, it will be negative. So we have negative 100 sine 90 degrees. Now let's finish this. We know that sine 90, cos 90 is 0. So 100 times 0 will give you 0. Then sine 90 is 1. So negative 100 times 1 will give you negative 100. Now we need to add all these forces, because they say the forces are in equilibrium. So we add all of the forces and it must be equal to 0. So let's do that. We have T1 plus T2 plus the weight must be equal to 0. So this is the 0 vector we are talking about. So the components of T1 were negative magnitude of T1 0, plus the component of T2 we have magnitude of T2 sine 30, magnitude of T2 sine 30, then magnitude of T2 cos 30, magnitude of T2 cos 30. Let me rewrite this one over here. So this is what we have. Then now let's go to the component of the weight, which is 0, negative 100, and all this must be equal to 0, which is a 0 vector. Now we can establish some mathematical relations using equations. So equating the horizontal components, we have negative magnitude of T1 plus magnitude of T2 sine 30 degrees to be equal to 0. So we can simplify this further to obtain negative magnitude of T1 to be equal to negative magnitude of T2 sine 30 degrees. So this implies that magnitude of T2 will now be equal to magnitude of T1 will now be equal to the magnitude of T2 sine 30. Let's call this equation 1. Now from the second component, which is the vertical component, we have the equation magnitude of T2 cos 30 degrees is equal to 100. Now we need to do some substitutions because we are solving for T1. So we can call this equation 2. We can simplify this further. Let's simplify it further. We can make T2 the subject, so magnitude of T2 will be equal to 100 over cos 30 degrees. 100 over cos 30 degrees. So let's call this equation 2. Now we saw that equation 1 is magnitude of T1, which is what we are looking for, is equal to magnitude of T2 sine 30 degrees. So we are going to substitute 100 over cos 30 wherever we see magnitude of T2 to obtain magnitude of T1 is equal to 100 over cos 30 degrees times sine 30 degrees. And now we simplify this, or we rewrite as magnitude of T1 is equal to 100 sine 30 over cos 30. And we know from basic trigonometry that cos sine 30 over cos 30 will be equal to, so sine 30 over cos 30 is equal to tan 30 degrees. Therefore the correct answer is option A.